see here, our circular linked list is nothing but a one-way connection, that is forward connection, right? And it only has a head but no tail, right? So the tail of the list will be connected to the head. That's why it is called as a circular linked list. That is, the address of this, okay, will be stored here, and the address of the first node will be stored in the last link of the list. Clear? Write down a circular linked list. A circular linked list is a list where all the nodes are connected, in the form of a circle. There is no tail in the list. It can be represented as, yes, right. Where is your book? It can be represented as a single linked list. Just put down one example. That is, the last node is connected to the first node. Just put that example. Just put down single linked list, no double linked list. Just put single. Put down some nodes. The last node is connected to the first node. Completed? Just put single linked list, don't put double. So this is just the difference between an array and a linked list. So what is the difference between an array and a linked list? Array is a linear data structure. Even a linked list is a linear data structure. In arrays, the data is stored continuously, whereas in a linked list, the data is not stored continuously, and this is static, right? And this is dynamic. Means what? You can give the elements, you can save the elements at runtime. Then this is easy to access because it only has single data type, whereas linked list will have multiple data types, so it takes time to access it, right? These are the simple differences between array and a linked list. You know the differences, right? Yes or no? So we spoke about dynamic memory allocation. Then write down the program. Write a program to implement circular linked list. Write a program to implement circular linked list. Now you all have to tell this program, because we have completed single and double linked list. Yeah. Yes, please stop talking now. Write down, write a program to implement circular linked list. Write a program to implement circular linked list. So put down the header files. You know the header files, right? Hash include stdio.h and standard library header file. Then put in the comments defining the node structure. So how do we define the structure of a node? Struct node, open brackets, then int data, the node will point to the next field. You know the diagram, right? Put down that. So you know this one. Write it. So this also is same. The pointer, by default, the pointer points to null because there are no elements in the list. Only if you learn single linked list, all these programs will be easy. Next, insertion at the beginning, same thing like single linked list. Write down, insertion at the beginning. What happened? You know that statement, right? Write down, struct node star head is equal to null. The head will point to null because there are no elements in the list. Next, next what you are doing? Insertion at the beginning of the list. Same like single linked list, you are inserting at the beginning, right? You are allocating memory dynamically, you are assigning value. Next, what you are doing? If head double equal to null. So you are not assigning next here, you are assigning if head double equal to null. What happened to you? Where is your pen? Huh? Ask someone. Idima. మరి ఏసీ ఆన్ చేస్తారా అవ్వదా అదన్నా అయ్యేది వచ్చినట్టు లేదు ఒకసారి చూడండి చాలా వేడి ఉంది ఇంకా So what are you doing here? You are taking a node, you are inserting at the beginning of the list, you are allocating memory dynamically, right? Dynamic memory allocation is done. Next you are assigning data to that node, right? New implies data is equal to value. Next what you are taking? If head double equal to null means what? If there is no element in the list, what you are doing? New node implies next is equal to, you are creating a new node. A new node is created. So here you will get like this. You are having a node with some value. There is null here. This is some 100th location. So as this is head, as it is null, what you are doing? New node implies next. So the next will become the new node. You are assigning a value to the new node. This will become new node. For this part. Clear? Next, write down else. If this is not there, else what you are doing? star temporary. So here we are creating a temporary node called as head node. Okay, which is the head. So the head will be the temporary node. So how do you draw the diagram here? So this is having some address 102, this is having 100, this is at 102, now this is null. So here struct node star temp, this was head, next this will become temporary node. Yes, stop talking. While temp implies next not equal to head, while temp implies next not equal to head, over, temp is equal to temp implies next. So you keep adding the next nodes in the list. Put down the diagram also. If you don't put down the diagram, you will not understand. Temp is equal to now for this, now I have already added some elements here. Okay, I am adding at the beginning of the list, so I am adding 4 here. This is 100, this is 102. As insertion is at the beginning, so you will write new node implies next is equal to head. So this will be the new node because you are adding at the beginning of the list. So temp implies next. So this was the temporary node, right? You are adding a new node at the beginning. Okay, so the head node will become the new node. This concept is for beginning of the list. అయిపోయిందా? Over? Shall we go to the next one? Next add-on, printf. Yes, stop talking. Okay. Yes, stop talking. Yes, what happened? Yeah, right on. Printf. Yes, stop talking now. You only talk when you are asked some question. Printf inserted percentile d at beginning. So what you are inserting at the beginning of the list? A value. Hello, both of you. What are you doing? Put your book on the top, please. Where is your mobile? Huh? PDF ఉంటే ఏంటి? నీకు రాయమని చెప్తున్నాను. మొబైల్ లోపల పెట్టు. You are inserting at the beginning of the list, right? Next, close brackets. So the insertion at the beginning of the list is completed. So when do you add at the end of the list? Is there any end? In circular linked list, there is no end. So the last element is considered as the end of the list. So what you are doing here? Same thing like single linked list. Write down insertion at the end. Put the comments. Insertion at the end. Void insert at end. You are adding the value, int value. Void insert at end, int value. Maatladadamma, please be quiet. So what you are doing here? You are allocating memory to the node. That is struct node star new node. So the memory allocation is same for all the programs. So you are writing here new node implies data is equal to value. So when will you start inserting? If head double equal to null, then you will write new node implies next is equal to the new node. Again you are starting from the beginning. So here you are adding at the end of the list. Already the list is created. You are adding at the end of the list. What is she doing? So here you are writing head is equal to new node, else. So if this is not empty, then you are going to the second part of the list. So when you are going to the second part, what do you have? You have a temporary node every time. Over? Next, write on. While temp implies next not equal to head. If the element which is added is not the first element, then you are going to add the element at the end of the list by using temporary. Temp is equal to temp implies next. So whenever you are adding the node, you are adding it as a new node. empty implies next is equal to new node, and new node implies next is equal to the head. Means what? You are pointing the last element to the beginning element. After adding, what do? You have to print the list. So printf, whatever is inserted at end, you will print that particular value. Completed? Next, you are not having anything at particular position because it's a circular linked list. It is connected from first to last. So here you are doing deletion from the beginning and deletion from the ending, right? So write down deletion from the beginning. So how do you delete? You will not allocate memory for deletion. You are checking whether the head is null, then the list is empty. If there is nothing in the list, you will print that it is empty. Else what do? You will start deleting from the beginning. The beginning is the head node. Completed till here. Yes, I don't want any sound. If you have not done, please say that you have not completed. Completed? Yes. So when the list was empty, you are printing this. Only when there is one node, struct node start temporary is equal to head. You are having only one node, then it will make it empty. After deletion, it will become the node which is empty. Completed? Yes? Next, go down. Whenever you are deleting, you are using free to delete that particular element, free of that temporary variable. So you keep deleting the elements one by one, and the last element will become the head node. Struct space node star last is equal to head, because it will point to the head node. That is the last node. So here last implies next means what? The first node. Okay. Next, what you are doing? Again, you are changing the head node. Head is equal to head implies next. Again, you are assigning the last node the value of the head element. Last implies next is equal to head. Next again, you are freeing the element which is deleted. and close this deletion at the end of the list. Completed? Next, so write on. After closing this one, you are deleting from the beginning. So printf, just a deletion. We don't want to know the node which is deleted because already I have given the node to be deleted. It will delete from the beginning of the list directly. Similarly, you are deleting from the end of the list. So when you start deleting, write on the function void delete from end, void delete from end. So what you are deleting here? By default, if the head is null, you have to check the condition. If the head is null, printf the list is empty. అయిపోయిందా? So if the list is empty, you are going to return it is empty, right? Else what will you do? You are going to start struct node star temp is equal to head, the head node. So here, if head implies next is double equal to head, if there is only one node, what will you write? Head is equal to null. Then you are deleting that node that is free of that temporary node. Insertion is done, deletion is done. Next what you have to do? Display. Write on. Sorry, first let us complete this. This is only for the empty node. There is first node. We have not done the second node, the continuous node. Write on. Else, you are deleting from the last, right? So struct node star previous is equal to null. First you will make it null and delete that particular node. Next what you are doing? The last variable was the temporary variable and the before is not the head. Then you will perform this condition. While temp implies next not equal to head. So the last node which was temporary, the previous node will become temporary here. Next, this temp is equal to temp implies next will point to the first node in the list. Then again close brackets. Next, you have to delete that node, right? So previous implies next is equal to head, free of the temporary node. You are freeing the temporary node. Next, print that node which is deleted from the list. That is, you are just deleting the list. You are not printing that element. Next, what is the last one? We have done insertion, we have done deletion. Then again display. How will you display? So if there is nothing in the list, what will you print? The list is empty. Otherwise, you are going to take the position of that particular element and display them. Write down the comments, display the list. So void display, void display. So if head double equal to null, there is nothing in the list. printf list is empty. And you are returning the function. If the list is not empty, what will you do? You are going to print every node one by one. So struct node start temp is equal to head. Then what you are doing? You are just printing the elements of the list. So printf circular linked list. So for printing that you are using do while. Over. Add on printf the data which is being displayed so you are displaying the elements one by one, making it as temporary. Temp is equal to temp implies next. Next what you are doing? While temp not equal to head, so this is do while, that's why you put a semicolon here. While temp not equal to head, you are printing the head element. So here I have not written the output. How will you write it? 1 point to 2, 2 point to 3, 3 will point to 1 again. Clear? Over? Complete that. Next put down the side heading stacks. Unit 3 stacks. Avana. ఎంత అవుతుంది టైం 10 అవుతుంది 11కి వెళ్ళచ్చు. Your ma'am is there. తొందర రాపండి. Go and come first. Go fast.
పంపరా సార్ పిలుస్తున్నారు.
ఎవరు మ్యామ్? ఏమా?
ఆ అబ్బాయి హర్ష.
ఓకే. స్టాక్ కంప్లీట్ చేసేస్తాను. వీలే ఉంటే క్యూస్ కంప్లీట్ చేస్తాను వీళ్ళకి మధ్యాహ్నం ఆఫ్టర్నూన్. అరే నేను నెట్ ఆన్ చేయలేదు, సారీ. వచ్చిందా చూడు, ఇంకో మెయిలా వచ్చిందా? పంపించండి. Yes, now stop talking. Put your mobiles inside. 1 minute time దొరికితే మీరు మొబైల్ యూజ్ చేస్తారు. Write down stacks. Put down stacks. A stack is a linear data structure. A stack is a linear data structure which works in the form of last in, first out, that is LIFO, last in, first out, that is LIFO. That is the last element, that is the last element in the list. The last element in the list is the first element to be deleted, is the first element to be deleted from the list. Example, placing books in a bag. Example, placing books in a bag. So how do you define the size of your bag? First, before putting the books in your bag, we have to define its size, because I can put a maximum of some elements, right? So what you are doing there? How will you define the section there? In C program, how will you perform definition section? Do you remember? What are the different sections in C program? Documentation section, linking section, next one, definition section. So in definition section, what do? It is declared globally, that is above the main function. You are defining the size, okay, maximum size. For example, the maximum size of this class is 60. I say 60. Only 60 students can come inside. The next student who is coming inside will not be allowed. Okay, they will be deleted automatically. They cannot come inside. So similarly, stack is the one, that is, if the 65th student is coming inside, he is the first one to go outside. Okay, right on. We define a stack. We define a stack size. We define a stack size by using hash define section. We define a stack size by using hash define section. So here this is the diagram of a stack, right? The elements which are inside will come out by using pop. Okay, right on. The different operations of a stack, right on. The first operation, push function. So when you write operation, you have to put it as open and close brackets. Push function, that is to add the element to the stack, The second one is pop function, to delete the element from the stack. Third one is peek function, P-E-E-K. So what do you mean by peek? It displays the topmost element of the stack, right on. Peek function displays, what happened? Right? Peek function displays the topmost element of the stack. So just put down the simple diagram. So it is having insertion and deletion at one end only, right? Just put down this diagram. Yes, what happened? Over? Yes, please stop talking now. Next, so see here, there are two types of implementations of stack. Write down implementation of stack. Implementation of a stack is done in two ways. Implementation of a stack is done in two ways. The first one is by using array representation. By using array representation. Second one, by using linked list representation. By using linked list representation, now see here, how do you define a stack? Yes, please stop talking. Now just see here, this is a stack, right? Please stop talking, listen to this. This is a stack, so you are defining the size of the stack. I am defining, has defined the maximum size. Max size is 5. That is, I can place 0 to 4 elements into the stack, right? So when I am performing push operation, you have to identify where is top. Top means what? What do you mean by top? Top will tell you where is the stack position. Okay. If the stack is empty, you will write top is equal to what? What is top? Top is equal to -1. -1 means what? It is empty. Write down. To represent the stack is empty. To represent a stack is empty, we use top, which is equal to -1. To represent a stack is empty, we use top is equal to -1. Now what will you do first? You have to add the elements into the stack and delete the elements from the stack. So when you are adding the elements into the stack, you have to check whether the stack is full. Is this clear? When you are adding the elements into the stack, what you have to do? What should you check? You have to check whether the stack is full. When is the stack full? When the size is double equal to top -1. What is the size of the stack? When top is full, here I am saying top is equal to 5. Means what? So if I am placing the first element, top will become 0. This is A. When I am placing the second element, top will become 1. I am placing the second element, third element C, top will become 2. Fourth element D, top will become 3. And fifth element E, top will become 4. Right? I have defined the size as 5. So if I am adding F into the stack, what will happen? It will be deleted. You cannot add this element to the stack. Is this clear? So when you are performing addition, that is insertion, you are checking whether the stack is full. If you are performing deletion, what you should do? You should check if the stack is empty. Clear? So I put down this diagram. Example, add the elements. Yes, I don't want any other sounds. Add the elements into the stack. Add the elements into the stack, that is A, B, C, D, E and F, where the size of the stack is 5, where the size of the stack is 5. Here Here we can add the elements from 0 to 4, from 0 to 4. Head on. Step 1. Step 1. Initially the stack is empty. Initially the stack is empty. Step 2. Step 2. Check if the stack is full. Check if the stack is full. That is top is equal to max minus 1. That is top equal to max minus 1. As the condition is satisfied, add the element A to the stack. Add the element A to the stack. Yes, please write. Now top is equal to 0. Now again if I want to add another element, what should I do? Add చేయాలంటే ఏం చేయాలి? స్టాక్ ఫుల్లా ఎంటీయా చెక్ చేయాల్సింది. స్టాక్ ఫుల్ ఉందా లేదా చెక్ చేస్తాం ఇన్సర్షన్కి, రైట్? రైట్ ఆన్. స్టెప్ 3. Step 3. To add the other element, we check the stack overflow condition. We check the stack overflow condition. That is top is equal to max minus 1. Top equal to max minus 1. As top is equal to 0, we can perform insertion. Next step, write down. Repeat the above steps. Repeat the above steps. So when I am adding C, what will top become? Top is equal to 2. When I am adding D, top will become 3. When I add E, top will become 4. Now can I add F? Head on. We cannot add F. We cannot add F as the stack is full. So insertion not possible. So insertion not possible. Now write down this program for only push elements. Write a program to implement. Write a program to implement stack using arrays. So for arrays we don't require lib.h, right? So write down. First one is hash include stdio.h. Next I am defining the maximum size. Yes, stop talking. I am defining the maximum size. So here I am writing int stack of maximum. What did you take here? Maximum is 5. So I am reading 5 elements here. Here I am reading that the stack is empty. So these are global functions. Stack is empty. Then you start the push operation. How will you start? I just now said, void push of that variable. Here you are reading integers. If you want, you can write characters also. Void push of int x. So to push the elements, what you have to do? You have to check if top is double equal to max minus 1. Right? You are writing? What are you doing? Huh? So if it is max minus 1, what will you write? Printf stack overflow. You cannot add the elements into the stack. Yes, I don't want any sounds now. So for this, put down the diagram. If you don't put the diagram, you will not understand. Here the max size is 5, which is 0 to 4. We are writing A, B, C, D, E. So the top will become 4. So here, see here, the top size is 5 minus 1. It is satisfied. So print stack overflow. So I cannot add any element to the stack. So what you are doing? You are returning the function. Next, what you are doing? If the stack is not full, what will you do? You are going to add the elements one by one. So what it will become? Top will become 0. When you keep adding, top will become 1, 2, 3, top is equal to 4. So for that, what are the steps? This one. Write down. Stack of plus plus top. So you are incrementing the top and adding the element to the stack. So what you are doing here? First you are incrementing the top to the next step, then adding the element to the stack. Completed? Over? Yes or no? Go to the next one. As you have completed insertion, for deletion what you have to check? I said what you have to check? It is underflow. Underflow means what? If the top is empty, you cannot perform deletion. Right? Write down. Void pop. Void pop. If top double equal to minus 1, if top double equal to minus 1, printf stack underflow. We cannot delete the elements. So return. You cannot delete, you are returning that function. Otherwise what you are doing? You are directly deleting the element, then decrementing the stack. Clear? So here you have to put this diagram. See, I am having top is equal to A, which is 0. Now when I delete it, first I will delete the element, then decrement the top. So it will become top is empty, which is equal to minus 1. Put down this one also. So top minus minus. In the first one you have incremented, then added the element. Here you are deleting the element, then decrementing. Here you are performing post decrement operator. See this. Over. Put down this diagram. Next, Next write down peak operation. So what is peak I said? It is going to show you the topmost element of the stack. So for that what is the condition? If top double equal to -1, printf stack is empty and returning the function so if it is not empty, what do? You display the topmost element. So top element %d/n comma stack of top. Please get up from there. Come this side. Get up. Come out. Come out. Sit to this side. So you have done push, pop and peak. Then what you have to do? You have to display the elements. I said get up and come this side. So how do you display? Write down void display. Ikkada daka ayipoyinda? Have you completed this? Yeah. Write down void display. So how will you display the elements? From down to top or from top to down? How will you display? From the topmost element to the last element you have to display. So what you are writing here? For int I is equal to top, I greater than or equal to 0, I minus minus means you are displaying the fourth element, third, second, first and the 0th element. So when you are decrementing that, when you are displaying that, you are printing that element. So what will you get in the main function? Main, push, pop and display, peak, right? So for this write down int main, open brackets, avaleda. Over. Next write down push, I am pushing the element 10 onto the stack first, then I am pushing 20 onto the stack, similarly push some set of elements, then display the stack and then you are popping the elements from the stack. So which will be popped by default? The last element will be popped, you need not select that element, right? Then I am using peak function. అయిపోలేదా? Close. This is a simple program, please execute it. Fast execute cheyali. It is very small. While executing only you have to understand what is the program. Please open your laptops. If you don't have laptop, open your mobile, open online C compiler and execute this program faster. It is a very small program. Exactly 10 minutes I am giving you. Do it fast. Yes, do it fast. Yes, have you completed? It is a very small program. I don't think it will take much time to complete that program. Till it is connected, you have to complete. Let us see how fast we will type. So here the diagram will be for this part. You are having a node, right? You are having a stack. So when you are adding data to the stack, top will become 0. Right? Here you are going to write new node implies data is equal to the element, and this will become the next element which is to be pointed. That is the next element where you have to add. Next, so this will become again the new node which is to be added. So you are linking a single linked list with a stack. Please put down this diagram. Yes, stop talking. అయిపోయిందా? Next, what you are doing? You are continuously adding the elements using this function. Next, what you have to do? Write down pop function, void pop. So if there is nothing in the stack, you are printing stack underflow. You are returning the stack, that is it is empty. Next, what you are doing? Struct space node star temp is equal to top. What do you mean by that? The topmost element in the stack will be pointed to the single linked list, right? Then you are deleting that element. Yes, someone is talking from the girl side. Yes. Here, if top double equal to null, printf stack underflow. Last row. What happened? So if there is no underflow, you are deleting the elements. So struct node star temp is equal to the topmost element is deleted. You are printing that element. Again, the top is going to the next element and you are freeing that temporary memory location. Completed. Next, peak. Have you completed this part? Yes. Go to the peak function. Peak. So void peak. So if top double equal to null, you are printing that the stack is empty. Else what you are doing? You are printing the topmost element of the stack. Yes, I don't want you to talk. Please be quiet. You only stand up. The front one. Nuve, ninjo. Please stand up. You only stand up. Yeah. Now tell me what you have done till now. You are only talking to that fellow. Huh? మంచి ఏసీ కింద కూర్చున్నావు, ఎంజాయ్ చేస్తున్నావు, అంతేనా? చదువు చెప్పినా వినరు. అంతగానే ఏం ఉంటుందమ్మా మాట్లాడడానికి మీకు? Can you define a stack? You only define a stack. పుట్టకొస్తే ఒక అక్షరం రాదు. Useless fellow. Sit down. Sit. మళ్ళీ ఏదో హ్యాపీగా నవ్వుతాడు సన్మానం చేసినట్టు నీకు. Next you are displaying the elements. Write down. How do you display the elements? The topmost element is displayed, then you are going to reach till the null element. So for display, struct node star temp is equal to, the temp will be the topmost element, then temp not equal to null. Till then you have to display the elements. You are decrementing the stack here. Over. Next what you are doing? You are having the main function. So what you are doing? You are calling the different push and pop functions. Write down int main, push the set of elements, display the list, you are doing pop, then you are doing peak function. You can call it multiple times. Now this is also a small program. Please complete it. Then we will see the diagram representation of that. And now after that I want you to ask me any doubt. Doubt రావాలంటే ఎప్పుడు వస్తుంది? మనం వింటే వస్తుంది. మనం ఏం వినకపోతే ఎట్లుంటుంది అట్లనే ఉంటుంది. It is like newspaper reading for me. No one is listening properly, only some students are listening, 1 or 2 or 3. Others are just enjoying with your neighbors. Till now you have not got any doubt? Huh? If you don't get any doubt, either you are 100% perfect or I am 100% perfect. There is no communication between us. Yes? Now execute this program, then I'll ask one of them, I'll show the diagram, you have to explain that diagram with the program. Please be prepared. When you are executing it, see what you are executing. Do it fast. I'll call one of them, like your TTL, what it is that. I'll put the diagram, you have to explain it, linking with the program, fast. I may call anyone. Don't come and just stand here. Do it fast. Execute the program, be fast. I may call anyone here, so better be prepared before coming. Now just see what are we doing here. It is a very simple program. When you are taking a stack, by default the stack is -1. Right? Now how are you linking to the node? You are taking a new node as the head node. Right? So by default this is null. Then you are allocating memory to this node. For example, I am allocating character. So this will be 1000. Right? When this is at the 1000th location, when I am adding element to the stack, top will become 0. So when top is becoming 0, this element is added to the linked list. Clear? This will become the head node. Right? Next, again you have to create a new node when you are adding the element to the stack. I am adding a new node, linking it. This will become B. So here this was the new node. Now this will become the new node. New node implies next. Clear? So when this becomes the new node, so the address of this, as it is a character variable, this is 1001. Right? 1001 will be stored here. So when I am adding, first when I am adding B to the stack, top will be incremented. Then this B will be added to the stack node. Right? So this will become null. So when are you adding the elements to the stack? When top is not equal to overflow condition, then you are adding the elements to the stack. When the top is under underflow condition, you cannot perform deletion. So when is it underflow? When you say stack is underflow? When is the stack underflow? Underflow అంటే empty ఎప్పుడు ఉంటుంది? Top is equal to -1. When you say overflow? Max -1. Right? So whenever I am adding elements to the stack, so here the nodes will be created. This will become the new node. Right? Then how do you start deletion? So this is C. This will become null. Right? So when I start deleting, I am going to delete this element. I cannot delete any other element other than the topmost element. When that is deleted, top will decrement to 1. So this node will be deleted. So when this node is deleted, this address is removed and it will become null. Is this clear? So whenever you are adding, you will add from the first to the last. When you are deleting from the last. So whenever you are linking a stack and a linked list, you have to create a node and allocate memory for that. So once you allocate memory, these two will be linked. Linked ante link undadu. So ikkada emaithe jarugutundo same operation ikkada jarugutundi. Clear? So what do you get in the answer? You will get C, B, A. So this was the first element inside. This is the last element. So this will come outside. Clear? This is stack using linked list similar to array. Array ante enti? You represent an array like this. Right? I put at A of 0 as A of 1 is B. This is called as array representation. This is called as linked list representation. Is this clear? Yes? Just write down the output there. For the program, write down the output. It is 30, 20, 1. Sorry, 10. 30, 20, 10. First 30, below 20, below 10. So after popping, the elements will become 20, 10. And the topmost element is, which is the topmost element? 30 is deleted, right? 20 is the topmost element. Clear? Now please put your laptops down, close them. You already saved the programs, right? Please close it. Put your mobiles inside now. Write down applications of stack. So where all you can use stack? Write down applications of stack. Please put your mobiles aside. First one is stack can be used for expression evaluation. So what do you mean by expression evaluation? Cheppandi. What are the three types of evaluations? Infix, prefix and inkoti enti postfix notation, right? So you are going to evaluate them now. Next, stack can be used. Those two boys, I don't know what they are doing. A row complete, 3 members, I don't know what you are doing. Meer muggure. Stack can be used to check parentheses. What are parentheses? What do you mean by parentheses? Open and closed brackets. In the program, when you put open and closed brackets, we use stack to check them. Right? Right on. Stack can be used to check parentheses, matching in an expression, can be used for parenthesis matching in an expression. Example, A plus B into C. So if you find one open parenthesis, definitely you need to find a closed parenthesis. The next one, stack can be used. Stack can be used for conversion from. Stack can be used for conversion from one form to another form. Yes, there is disturbance. Please be quiet. So what are the different forms? Infix to postfix, to prefix or postfix. Again, prefix to postfix. Any type of conversion it will do. Next we have problems. So better don't sleep. Next write down. Stack can be used for memory management. Stack can be used for memory management. Next one, stack can be used in backtracking. What do you mean by backtracking? Stack can be used in backtracking. Backtracking ante enti? What is backtracking? Yes? Backtracking ante enti? For example, write down. Example, I have written 3 plus 7 into 5. Okay. By mistake, first of all, how should I solve this problem? That white shirt. You only. Yeah, please stand up. What are you doing? You are writing? Yeah, tell me how will you solve this problem? What is the answer for this? Maatladadama. What is the answer? How will you solve this one? First sem lo chepparu kada meeku? Cheppaleda? Expression evaluation leda? Which expression will be solved first? Yes? You don't know. Which expression will be solved first? A expression. Yes, sit down. So which one will be solved first? First multiplication will be solved, then plus will be solved, right? So I am doing wrong here. So I am doing first 7 plus 3, 10 into 5. I am doing it wrong. Okay na? So ippudu nee ikkada chesin tarvata I got the answer 50. But in my system it is showing the answer as 38. So what will I do here? I am backtracking. I am going back from the answer. I am going to the question and solving it from the back till the first. అంటే ఇక్కడ మనకు ఆన్సర్ ఇచ్చారు, ఆన్సర్ నుంచి క్వశ్చన్కి వెళ్ళి దాన్ని సాల్వ్ చేసుకుంటూ వస్తున్నాను. మళ్ళీ రిపీట్ మీన్స్ వాట్? ఐ హ్యావ్ డన్ రాంగ్ ఇన్ దిస్ స్టెప్. సో వేర్ డిడ్ ఐ డూ రాంగ్ ఇన్ దిస్ స్టెప్? మీన్స్ I have to go back to this step. Here I have done wrong. So what will I do? This is called as backtracking. Clear? So first what you have to do? 35 plus 3. So the answer is 38. So this process of going back is called as backtracking, and stack allows this backtracking. Clear? Go to the next one. Write down representation of an expression. A representation of an expression can be represented. An expression can be represented in three ways. An expression can be represented in three ways. The first one is infix expression. Yes, write down infix expression. Second one is prefix. And the third one is postfix. Next, so what is infix notation? You write a plus b, so it is in that process only a plus b రాయడం దాన్ని infix notation అంటారు. Write down the process of putting the operators between the operands is called as infix notation. Call him. Please stand up. Stand up. What is infix notation? Stand up. Yeah, what do you mean by infix notation? You are acting too smart after telling so many times. The next one. Call him. ఏం చేస్తున్నాను? ఇన్ఫిక్స్ నోటేషన్ అంటే ఏంటి చెప్పు? What is infix? You please take their numbers, give them absent amma. వాళ్ళ ఇన్ఛార్జ్ చెప్పండి. From so long I am saying you both are not listening. Write down. Example a into b plus c. Sit down. A into b plus c. So here what are the operands? A, B, C are called as operands and the operators are plus and star. Yes, stop talking now. Next, write down postfix notation. So what is postfix? So the same expression you are representing operands then operators, right? Write down operators are written after their operands. Operators are written after their operands. The postfix notation is also called as suffix notation. You know what is prefix and suffix? Yes, suffix means writing at the last, prefix means writing at the first. Suffix notation or reverse Polish notation Example, put this example, this one, A into B plus C divided by D. So how will you write this one? So first you are solving the operands which are in the brackets, B, C. You write down A, B, C, then you are going to put plus then you are going to do multiplication, then division. So you will get the same answer when you do that expression. Next one, prefix notation. Write down prefix notation. Operators are written before the operands. మళ్ళీ మధ్య operators are written before the operands. The prefix notation is also called as Polish notation. Now see here, example, just put down this box, listen carefully, you will get this problem for 5 or 10 marks. There are steps to convert, direct convert cheyaru. This is infix notation, normal notation. So ee rendu madala plus operator edaithe undo then forward lo rastanemo prefix. If you write it backward, that is called as postfix. Similarly here you are doing a plus b into c plus d. So between them, which is a combined operator? Star. Again, between C and D, you are going to do plus. Between A and B, you are going to do plus. So you are going to write it, the operators first and then the operands. So here you may get a doubt, why did I write C and D first? So C plus D, A plus B is same. Both are of the same form. So you can put AB, then CD. Clear? Again, in postfix, what you are doing? AB plus CD plus the last one is star. So the operands first, operators later. Similarly here, b square minus 4ac. So what you are doing here? First you are doing minus, then star c star a to the a into 4, right? A4 into, then bb. So for this bb you are putting into. Clear? Similarly here, bb star 4a star c star then minus. So there is a procedure to convert it, okay, which we can do it later. First take down this example. Over. Now see, just I'll show you this one. You have to do the conversion like this. So this expression, what is there? You have to solve it like this. You are pushing this expression onto the stack, right? So here you are having postfix expression. You are converting the infix to the postfix expression. This is important. Clear?